So in this today's session, we'll look at the digital logic circuits and its component. Okay, here is the syllabus present as per UGC Net. It has digital computers, logic gates, Boolean algebra, map simplification, combinational circuit, flip-flops, sequential circuit, integrated circuit, decoders, multiplexer, and memory units. So we'll we'll understand all these theories through this session. So let us look at the digital computer first. We have already seen it, but before going into the computer internal part, let us review it. What is a computer? Computer is a programmable electronic device, and it follows the von Neumann stored program architecture. That's where the memory comes into the picture. We write a program stored in the memory, and CPU reads the instruction present in the memory and execute it accordingly. We have four types of computer. First one is microcomputer, which we are using today, like laptop, desktop, laptop. All these are single user systems. Then we have mini computer. Mini computers are multi-user servers. If you have seen some server in your lab, those servers can handle hundreds of users, and those are multi-user systems. They can handle multiple users at the same time. There are systems like N computing, which handles 30 computers per server. That is also a multi-user server, and that comes under the mini computer. Then we have mainframe computer, which are the enterprise system servers, which can handle more than 1000 users. Those are also multi-user systems, but those are for enterprise like companies like Infosys, TCS. Those development companies are using this kind of mainframe server to manage their systems. And next is your supercomputer. These computers are very efficient in computational, and it does millions of instructions per second. And all the operation like weather forecasting, disaster management, it requires to manage and process a huge amount of data. For that, we need a very fast processor, and this requires millions of instruction processing per second. And for that, we have supercomputer, where we have thousands of processors together, and they do tasks that is assigned for that. Now let's talk about a very fundamental idea of differentiating computer. One is multi-user, multitasking, and multi-programming. All sound similar, though there is a subtle difference among them. If you say multi-programming, it talks about the capability of the programmer to write more than one program and stored in the memory, and the system supports to run those programs at the same time. Even though the system doesn't execute more than one program, more than one instruction at the same time, but the user feels as if there are more than one programs running at the same time. With respect to the speed, processor is very fast, so we can write program 1, program 2, and program 3, and we can load all three programs into the system and feel as if the CPU is running all three programs at the same time. So with respect to programmer's point of view, it is multi-programming. What is multitasking? Multitasking is with respect to the task associated with that program. A program 1 is used to display something. Program 2 is used to play some music. Program 3 is used to copy something. So displaying, playing music, and copying some data, all these are different tasks. So who requires this task? User requires this task. So in this perspective, users' point of view, systems are taken as multitasking. The systems which provides more than one task at the same time, that is called multitasking system. Then multi-user. Multi-user is very understanding. If more than one users are using the system at the same time, that is called multi-user system. And here, it is not that the users one is spend some time on the system for a few time, then user two will come and spend and execute something. It is the user one, user two, and other users will use the system at the same time. Okay. And if you take the example of Windows 10 that we have in our computer, is single user system. It doesn't provide interface for two different users. I have one keyboard, I have one mouse. I can use a single user can sit in the system and work. But there are, there are systems which has multi-user operating system like server editions, Windows Server Edition, Server 8, Server 12. Those systems are designed to handle more than one user at the same time. That's why it is called multi-user system. Yes? Is there any doubt so far? Is there any doubt so far? Okay, I guess there is no doubt here, so we'll proceed further. Let me clear all the drawings and go to the next. So in a typical computer, there are two types of logic gates. Okay, one is your combinational logic, and the one is your sequential logic. One is combinational, the one is sequential. You might have studied it. Let us see it in a different perspective. So logic blocks whose output logic value depends on the input logic value. So combinational logic, like say logic box, where you give input and you directly get output. You don't have to do anything. I mean, there is a simple thing. You provide input and you get the output with respect to logic defined in the logic box. Sequential circuit is also a combinational circuit. It's also a combinational circuit. That means it takes input and it gives output. Nevertheless, it also has a feedback mechanism. I mean, the output will be taken to a memory unit, and that output of memory unit will be inputted to the logic gate in later period of time. So how this is different from combinational circuit? Conventional circuit is you provide input with a stipulated period of time you will get output. There is no feedback system. But in case of sequential logic system, what happens? This is a conventional circuit. This one is a conventional circuit which takes input, which has also output, but it has a mechanism of storing the output in memory, which can be later be inputted to the system L. Okay, so two different types of logic gates are present. We'll see what are the different gates. Functional, let's talk about the functions of gates and how it can be described. It can be described with the help of a truth table, Boolean function, and it will be simplified with the help of a Karnaugh map. We'll see three things. These are the different gates that we have already seen in our theory classes, like AND operation, OR operation, inverter, buffer, NAND, NOR, exclusive OR, exclusive NOR. So let us review it again. In case of AND gate, the output is only 1 if both the input are 1. In case of OR gate, output is 0 if both the inputs are 0, otherwise 1. In inverter, it is the complement of the input. If 0 is 1, 1, then it will become 0. Buffer, it's simply 0 will be transferred as 0, 1 will be transferred as 1. It is simply a memory unit. The NAND gate is it works as a negative AND gate. So we have AND gate here, this is a NAND gate here. So output is 0 only when both the inputs are 1. NOR gate, the output is 1 only when both the inputs are 0. Here, the output is 1 for exclusive OR gate. Output is 1 only when one of the input is 1. Did you see the output? Output is 1 only when one of the output is 1. If both the inputs are 1, it will be 0. XNOR gate. So how it works? It will be 0 if only one the input is 0. And this can be represented at A bar B bar plus AB. Okay, I'll return to this expression later. By using this expression, we can extract this. By using this truth table only, we can extract this expression. How this is? We'll see this 1 or the output to 1 can be seen as a mean term. Mean term, that means this is the mean term. So 1 equal to A, which is represented as 0. Here B is represented as 0. That means it's a complement form. If I consider A is equal to 1, the complement form of A is 0. So it is A bar B, if I consider 1 as B, then 0 is B complement, then A bar B bar for 1, A bar B bar for 1, and here A B plus A B for this one. This is A bar B bar plus AB. Similarly, here also for exclusive OR, you have this min term 1, which says A bar B plus A B bar. Okay. So next we'll see what are the algebraic property present in Boolean algebra. So initially we'll see what AND operation does. It says if 0 is ANDed with any variable x, the value will always become 0. If 1 is ANDed with any variable x, the result will be x. Similarly, the OR, if we OR with 0, it will become x, and if you OR with 1, it will always become 1, because 0 plus 1, 1, 1 plus 0 is also 1. Complementary AND operation, x is ANDed with complement of x will become 0, and complement of x is OR with its own value x, it will be equal to 1. Commutative, the AND and OR operations are support commutative attribute. That means x dot y equal to y dot x. Similarly, x plus y equal to y plus x. Distributive law is very similar to your normal arithmetic, like x and y plus z equal to x and y plus x and z. Don't confuse with multiplication and addition of arithmetic. This is with respect to Boolean function. So dot represent AND function and plus represent OR function. Okay. The plus is not arithmetic plus and dot is not arithmetic multiplication. Rather, these are AND and OR respectively. So here x plus x plus y dot z, that means x or y and z will be equal to x or y or z. Next, we'll talk about absorption law. Sorry, this is not D, it is B. It is typing mistake. AB absorption law. X plus xy. This I have, for writing convenience, I have omitted the dot. So if anywhere I write, excuse me, xy, it means x dot y. So x plus x dot y equal to x. How it will become x? If you take common, x can be taken common from this x taken 1 plus y. So 1 plus y equal to always 1. So x dot 1 equal to similarly here x dot x plus y equal to x. Look at this. X will be multiplied with x, not multiplied actually. X is ANDed with x, it will become x. X is ANDed with y, it will become xy. So this is similar to the upper one, and the value will become x. X or x complement and y equal to x or y. Why it will become like that? If you take y here, we can simplify it with the help of corner map and find it out, and we'll see it later, but this will be the output. X or x complement y equal to x plus y. Similarly, x ANDed with x complement plus y equal to xy. So what it says, if you have any variable x and any other variable y is ANDed with the x complement, the value will become x and y, and this x will be deleted. X complement will be deleted. Similarly, with the ANDed operation, x is ANDed with y or x complement, then x complement will be deleted and x and y will retain its value. This is why it's called absorption rule. So I'm deleting this x complement. Similarly here, this value are not committing any, not contributing to the value, rather it will remain x. Similarly, x plus ANDed with any x value will become x only. So these are getting deleted, and the only value x is retained here in the first example, and here x plus y is x plus y and x dot y are retained, and other two example respectively. Is there any doubt so far? Is it okay? Can you hear me? Okay, okay, okay. Next is your De Morgan's law. What De Morgan's law says, the complement of all variables will be equal to AND operation of the complement of individual component of the value. That is, x plus y to get the whole complement will be equal to x complement dot y complement. X dot y whole complement will become x complement plus y complement. This is not only for two variables. If you extend it for n different variables, it look like this: x1 plus x2 plus dot 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 plus xn complement whole complement will be equal to x1 complement dot x2 complement dot xn. The reverse is also true. This is called dual. We'll see what duality principle is. Here x1, x2 till xn all are ended and whole complement is taken and be equal to individual complement, that is x1 complement x2 complement till xn complement, and they are odd. Okay, now look at the logic circuit design. What initially been done, they will provide you similarly, they will provide you this Boolean functionality with the help of these inputs and output. And you are supposed to design the logic diagram for the particular input and output. So what is usually been done for every operation, this input and output are taken into consideration and its corresponding kernel map is designed. And from the kernel map, this is the kernel map. From kernel map, a simplified function is obtained, which will probably have less number of logic gates. Hence, the cost will be reduced. So, how it is being done? Look at this. Here we consider 1 as the mean term. 1 in the output are mean term, whereas 0 are termed as max term. So these are my mean term. Okay. And we'll represent this mean term and max term in this column. How we'll do this? We'll design a 8 output box. Here it is, outputs are 1, 2, 3, 4, 5, 6, 7, 8. So we'll put 8 boxes here and the composition will be X, Y input and Z input. So X value is 0, Y value is 0 and Z value is 0. Then it is 0, 0, 0. So this is your X value, this is your Y value, this is your Z value. For every box, the corresponding values are provided here. Okay, and the common value with that column is signified. Like 1, 1 is common here. So this 1, 1 is taken here. So 1, 0, 1, 0. So 1, 0 is common. So that means 1, 1, 0, 0 will become 1, 0, 0. This is the index of this position. So we have X and Y input and Z input. Okay, no query. So 0, 0, 1. So what is 0, 0, 1? 0, 0, 1. This is my position. So I will have max term as 1. This is my max term. Sorry, mean term. So I place this mean term here. Now I have mean term like 1, 1, 0. I have mean term 1. So 1, 0, 0. I have mean term 1. 1, 0, 1. I have mean term 1. For 1, 1, 0. I have mean term 1. For 1, 1, 1. I have mean term 1. For quick uh, positioning, we can write the value again. 000 is 0, 001 is 1, 010 is 2, 011 is 3, 100 is 4, 101 is 5, 110 is 6, 111 is. If values are not fixed, I can write x here, I1, y here, and z here, and accordingly the value will change. If I write x in this axis and yz in this axis, then accordingly its value will change. So x, y, and z. That's why it is 0, 0, 0, 0, 1, 0. Okay. Okay. So if you see that we have common element like this is the midterms. So we'll use our corner map principle. We'll see it and we'll take the common element by pairing them. So 1, 1, 1, 1 we can pair as required and we take the common element from this branch is 1. So value was x, y, and z. So first value is x, second position is y. So x is taken common. So 1 implies x. And in the other case, like second pair is this and this. Here what is the common element? 1, 0 is common. So is it common? 1, 0 and 0, 0. What is common here? 0 is common. So 0 signifies y bar. So it is y bar, and within this row z is common. So y bar z. That's why it is called x plus y bar z. And its corresponding gates are implemented here. X, y bar, z. And y bar and z are ended. Y bar z are ended. And the output of that is odd. OR operation is designated by this gate, and ultimately you will get the F output. So what is usually done? You write the input, you write the corresponding output, you select the mean term, all the one output as termed as mean term, and you place in its corresponding position. You form the quad or square or binary or octa, the 8 pair or 4 pair or binary pair, and accordingly you derive the simplified functional output, and then you realize with the hardware logic diagram. This is the process of doing that. You have the truth table. You have the truth table defining, stating the input and output. You use the column map, and you will get a simplified Boolean function. We have a truth table, and it signifies a Boolean function. That is, it requires so many of logic gates. which is costly. So for simplification, what we do, we take the help of kernel map and we get a simplified Boolean function. So we use kernel map for simplification. Okay. Is there any doubt so far? Okay. So what will we do? We'll take a small test and see if we have understood it. Is switching function. The function is given here. F of A, B, C, D. A, B, C, D are four output, and its corresponding function is written here. So what is the function? A bar is designated as 0, B bar is designated as 0, C is 1, D is 1. So it's 0, 0, 1, 1. Complement form will be designated as 0, and its true form and the position of C in its normal form will be treated as 1. So similarly, this value will be like 0, 1, 0, 1, and we'll have other as well. Now, can anyone tell me what will be its positional value with the measure function m? This is termed as mean term. Okay, so when you write max term, we signify pi, and we state the position of the max term. All the zeros outputs are termed as max term, whereas all the one are termed as mean term. So here all, if I have A bar, B bar, C, D, then I'll have output as 1. Okay, this is what mean term says. So 0, 0, 1, 1 will give output 1. In our example that we have seen earlier, here this 1 is mean term. What it says? X bar, Y bar, Z. X bar because it's a 0 and the first position is for X. 0 is the complement form of X, that is X bar. 0 in the Y position is complement form of Y. So Y bar Z. So X bar, Y bar, Z is equal to 1. Plus, so this is my product form. X bar, Y bar, Z plus the first mean term is added or with second mean term, that is 1. X, Y bar, Z bar plus X, Y bar, Z, third mean term. Then plus fourth mean term, that is X, Y, Z bar, and fifth mean term, X, Y, Z. So by seeing this implication, can you give what will be its answer? Type your answer in the answer box. Yes, Soumya, is there any problem? Do the question one and type the answer. So first component is 0, 0, 1, 1. Its value is 3. So 3, 3. Then complement form is of A is 0, B is 1, complement form of C is 0, D is 1. 0, 1, 0, 1. So its value is 5. 5. Then complement form of A is 0, B 1, C 1, D 1. Its value is 7. So here it is. So we have seen 3 are correct. I hope rest 2 are also correct here. It will be 9, I guess. 1, 0, 0, 1. So yes, it is 9 values. Then 1, 0, 1, 1, 11. So B option is correct. Did you get the answer? Yeah, the complement value must be 0. The complement will be treated as 0. Okay. Now look at the next question. The switching function f a b c d equal to its positional value is given 5, 9, 11, 14 can be written as is the reverse of question 1. So initially what was given? It is positional values are given and you are supposed to position values are given in sum of product format. That is this is one product and that these are all products of four component A, B, C, D and all are ended. Sorry, all are OR combined with OR operation. So these are sum. Usually we call it a OR function as sum. So sum of products. So what will be the answer for second question? 5. It should be like 0, 1, 0, 0, 1, 0, 1. Yes, 0, 1, 0, 1, 0, 1, 0, 1. Okay. Okay, let us see. Jaya says A is the answer. Let us see. 9. So 1, 0, 0, 1. Yes, it is 9. So obviously, yeah, very good. It is A is the answer. Next question. The switching function f of a, b, c is provided here. Now it is in product of sum format. Product, there is product or AND operation of individual sum operations. And now each individual product of sum is nothing but output as 0. So A plus B bar plus C, if this value are active, then we have output as 0. A bar plus B bar plus C, if these values are in in function, then the value will be 0. Did you get that? Let me take you the result drawing and let us go to the slide that I have covered. Here, this 0 element can be designated as x plus y plus z. This is x plus y plus z. This is one sum element. This 0 is another sum element. How? X plus y bar plus z. X plus y bar plus z. Again, this 0 is another element. X plus y bar plus z bar. X plus y bar plus z bar. So all these sum are ended like x plus y plus z dot x plus y bar plus z dot x plus y bar z bar. This is the representation of product of sum. Let us go to the question. Now look at this question and try to find it answer. So here, this value, A value, will be treated as 0 and the complement value will be treated as 1 and C value will be treated as 0. Here is the reverse of this case. In mean term, for defining mean term, we take the help of sum of product. We'll take the help of sum of product. For defining max term, we take the help of product of sum. This is product. This is product. Here is the product. Here is the product, and here is the sum. So these are max term are represented in product of sum format. Mean terms are represented sum of product format. Now, what is value? 0, 1, 0. The value is 2. Then 0, 0. Sorry, it is 1, 1, 1, 0. The value has to be 6. The value has to be 6. Yes. Then 0, 1, 1. So value is 3. So here also A is the answer. Okay. Now, this is the reverse of third. The max terms are given. You're supposed to find out its product of sum format. So product of sum, here main terms are given. Sum m, this symbol is for mean term. So mean term, this is the positional value of mean term are given, and you are supposed to find out its corresponding max term. So if we have 0, 1, 5, 7 as the mean term, and we say we have three elements here, A, B, C as input. So what are the possibility of outputs? Assuming each of the value can take two value. So A can take two value, the 0 and 1. B can take two value like 0 and 1. C can take two value 0 and 1. So we have 2 into 2 into 2 to the power 3 is equal to 8 possibilities. So we can have possibility from 000 to 111, 8 different possibilities. And if 0, 1, 5, 7 are reserved for 0, then other position will be reserved. Other position can be filled with 1. So what are the value left? 0 is occupied with 0. 1 is occupied with 0. Sorry, these are mean terms. So those are 1. 0 is occupied with 1. 1 position is occupied with 1. Then 2 will be filled with 0. 3 will be filled with 0. 4 will be filled with 0. 5 is occupied with 1. 6 is free, so 6 will be filled with 0. Then 7 is occupied with 1. Did you get this? So simply this is the mean term union pi term is equal to the whole set or inversal set of this function. So f a b c can range from 0 to 7. So 0, 1, 5, 7 is mean term. So left terms like 2, 3, 4, 6 are max term. The three variable switching function is expressed as product max term by f a b c is equal to 0, 3, 5, 6. Then it can also be expressed as sum of mean term by this is the reverse of fourth question. Here max terms are given. You're supposed to find out its mean terms. So do it and tell me the answer. Type the answer in the chat box. Tell me the answer of question number 5. Is it okay? Did you get the answer? This is very simple. 0, 3, 5, 6. Then the rest of the elements are 1, 2, 4, 7. And it is max term, so it will become min term. So that is what is called duality. If you are given with max term and you find the min term, that is called dual of one another. Okay. The dual Boolean function theorem, x dot y plus z equal to xy plus xz. It is the distributive function. Is what? What will be its dual? Dual, how do you find its dual? You simply convert the AND operation with OR and OR operation with AND. So X AND, so instead of what we will do, you convert it with XOR. So XOR, is there any XOR operation? Yes, this is the XOR operation and this is the XOR operation. XOR, XOR, Y and Z. So Y and Z should be Y, sorry, Y or Z should be Y and Z. Y and Z, Y and Z, it's okay. First part is correct for both A and C. X, Y. It should be X plus Y. X plus Y and X plus Z. So C is correct. Question number 7. Given Boolean theorem, AB plus A bar C plus BC equal to AB plus A bar C, which of the following is true? If this is given, then which of the following is true? Use in pen and paper and try to solve this. Okay, before going to 7, let us do the 7. 8 first. 8 is a bit easy, so we'll do it, but require a bit calculation. So we'll look 8th question first. What it says, A bar, B bar, C. The A bar plus B bar plus C bar whole complement is equal to which of these options? So you may apply directly de Morgan's law. So this will become, you open the bracket of full complement and individual element will be complemented and ended. So A complement complement, that is A, dot B complement complement, that is B, dot C complement complement. So A dot B dot C will be the answer. If you see 9th question, AB plus A bar C plus BC is equivalent to which of these options? AB plus A bar C plus BC. You try 7 and 9 and tell me the answer. Try to find out. A will be the answer. For 9, if you apply absorption law, the BC will get deleted. Just try to do that, and B will be the answer for that. Okay, this is the basic lesson for recognizing the mean term and max term, because many many questions are related to this mean term and max term. Usually students find difficulty in defining and recognizing the mean term and max term, thereby losing marks in other subsequent questions which involve this recognition. Okay, is there any doubt so far? If you have any queries, you can ask me. Otherwise, we will end this session here. Okay, okay. Let us solve it then. Jaya says seventh problem is bit. Okay, let us see. So what is the question? Question says AB plus A bar C plus BC equal to AB plus AC. So what it says, the BC component gets, yes, deleted. Now if you see it closely, this is the dual of it. AB is A plus B. A dot B will become A or B. A, A bar dot C will become A bar or C. B dot C will become B plus C. Corresponding its dual output will also change. A dot B will become A plus B. A bar C will become A bar plus C. So these two are dual of one another. If you do it, if you take the help of simplification also, you'll get this answer. But by duality, you can find the answer as A. This is how you can quickly observe and get the answer. Is it okay? Did you understand there? You don't need to simplify it. Just by seeing its form is the dual of one another. So both are true. If this is true, then its dual will be also true. Okay. How to find dual? Convert the AND operation with OR and OR operation with AND. Replace AND with OR with AND. Is it okay? Is there any other doubts regarding this session? Yes. 7 is duality problem, and 9 is absorption law. Same thing is given here. A B plus A bar C plus BC will become AB plus A bar C. Okay. If you apply absorption law, this BC will get deleted. So AB plus A bar C. Any element is or with A and A complement. If you take this, then this element will be deleted or absorbed, and you will get this is out. This we have already seen in our postulates. Okay. So I hope the doubts are clear now. So what have we decided that now onwards what we will do, we'll discuss small topic, we'll do this kind of multiple set questions so that our doubts will have our doubts, and once we discuss it will get clarified. And thank you for joining this session. So let me end this session here.